Hey guys, welcome back to my YouTube channel, and today we're gonna focus on chapter 12. So this chapter shows and covers advanced SQL features beyond basic select, join, and where queries. It focuses on how to structure queries using subqueries, derived tables, and STEs to write more powerful and modular readable queries. These are especially useful in analytics. So we have subqueries, queries within queries. Subqueries are select statements embedded inside another query. So they are useful when the exact value for filtering and comparison or computation is unknown beforehand and must be dynamically calculated. So in these cases, we'll use cases like filter with a calculated threshold and update the rows unconditionally, then delete data selectively, then generate derived columns. Another thing that I want to add in this chapter is that there are types of subqueries. We have scalar subquery, which returns a one value, and a table subquery, which returns multiple rows, and correlated subquery, which depends on the outer query. And then uncorrelated subquery is independent from outer queries. And then we have derived tables. In derived tables, we have subqueries in form clause. We also called inline views derived tables and let us perform calculations or filter abstract intermediate result. Now, our first exercise was that we were given a task that we should build um, a business employee data system, and our task was to capture employee information, then define the roles and input employees, then the query purposes. So we created a way to store each employee's birth name, job role, and role description and role salary. So as you can see here, I have the sales units, I have the role of the employee and the ID. And when I ran this, let me, how can I do this? Should I play this or already exists? Oh yeah, it already exists because I've created a table here. So this is my employee table, and as you can see, it has the dev ID, the full name, the email, and the role and the age. Then they say define the roles. You listed four specific roles, which is the role, the graphic designer description, and the salary. Do I have that? Let's see. We have developers. Let's see that table. Okay, we have the role, the dev ID, the age. Let's see. Retirees. Let's see our retirees if we get something. We have the last name, Janet, and all that. Licenses, courses, albums, vectors. I think I deleted that database. I'll come back to that. Let's just go to our what you call it, our practical, and see the try it yourself. I'll come back to it. Now we in chapter 12, advanced queries and all that. Let's go here. So the first task is that here are two tasks to help you become more familiar with the concept introduced into the chapter. Revise the code in listing 12, 15 to dig deeper into the nuances of the Waikiki's high temperature. Limit temps collapse table to the Waikiki's maximum daily temperature observation. Then use the when clause in the case statement to reclassify the temperature into 7 more groups that would result in the following text output. So let's see what we did. So the first step that we did, let's go to chapter 12. This is not chapter 12. Is this chapter 12? Chapter 11? Chapter 12? Yeah. So we have 90 or more, and 88 and 89 and 86 and 87 and so on. So in which of those groups does Waikiki's daily maximum temperature fall most often? So they say limit the terms collapse table to the Waikiki's maximum daily temperature, then use the when clause in the case statement to reclassify the temperature. Okay, so it is, they say it's between 86 and 87 degrees. Now we're gonna use this what do they call it, this statement, and see what we get. Let's just go here, fresh. Why is it giving me that? I don't want this. Paste. Let's see what we get. It says error, temperature does not exist from temperature readings. Okay. I guess I don't know about that. We should have created a table. Let's go to number 2. What do they want? They say revise the ice cream survey cross tab in listing 12.1. Flip the table in other words and make flavor the rows and office and the columns. Which elements of the query do you need to change? Are they counts different? So our answer was we need to reorder the columns in the first subquery, so flavor is first and office is second. Then we have the count statement that stays the third. After that, we must change the second subquery to produce a grouped list of office. Then finally, we must add the office names to the output list. So the numbers don't change. What changes is the order presented in the cross tab. So we're going to use the select statement from the table called cross tab. And again, we didn't even create a table for our cross tab. So I'll see, we're going to use AI on this also. Let's go here. We need to say create a table for this because it's giving me this. Now we're going to run this statement and just check. Same story. Okay, we need to create the tables for this. Let's start here. The width, okay, copy this, we put it in AI. This is how we work with our AI interface. We take our error and we say was the purpose to create a table? If so, please help me with that. We must not just say make this, we must know what we're talking about. You say, it says I'm absolutely right. The error means that the table temperature readings does not exist in our database, and if we just testing or learning SQL and want to run successfully, we first need to create the temperature readings table and populate it with some text data. So we're going to create a table called temperature readings, and take it here step by step. We put it here, paste it, then we insert the sample data, wacky whatever, inside of it. And then now we're gonna run that query after running our statement. So we run our create table, which created our table called temperature readings. Then we insert our values inside our table called temperature readings, and the values have their own columns and parentheses separated by commas. Then we run this, insert it, then we can run this with statement. Yeah, let's run it. Bah, we have the maximum. So what was the answer for let's try it yourself here. They say, in which of those groups does Wakiki's daily maximum temperature fall most often? So let's see where it falls. It falls most often between 90, falls more 82 and 83. What do they say here? 86 and 87. Yeah, it falls most here. There, Waikiki 717.2, right? Wakiki's high temperature. Limit the time collapse table to the Waikiki's maximum daily temperature and observations. Then we use the when clause in the case statement to reclassify the temperature into 7 groups that will result into the following text output. So yeah, between 87 and 86 here. So we're using our when clause. It's our when condition. When maximum temp, look at between 86 and 87, then you get that, and then end from the table called temperature readings, where the station underscore name column is equals to the Wakiki 717.2 HIUS. So we're looking for this specific value, right? It must match this specific value. Then that's where we get our 87 and 86. So we have the specific value 717 in all of these columns, but they want HIUS. How does it they want what? They want our maximum, right? In which of those groups does Wakiki's daily maximum temperature fall most often? So we're gonna look at our max temperature, our maximum. So our maximum will be 86 and 87. So there is it. Yeah, nice and simple. Then let's run our cross tab and see what we get. We're getting this error because we don't have a table called cross tab. Now I'm gonna copy this and tell AI if this is the same story, please create the table for me. If this is the same story as the one I pasted, please create the table for me. Yes, it is a different kind of error. So, but it's also because something is missing in our setup. So we are trying to use cross-tab function, which is not built in by default in Postgres SQL. Hello, man. Sorry for that, guys. Let's continue. So we had to do step by step fix cross tab. So we enable the table function extension. We need to run once in your database create extension if not exist function. So we're gonna run this and see what happens. Let's run this and see what happens. Let's see. Okay, successful and all that. You're still gonna get an error. Yes, I knew it. It does not exist. Select office. Ice cream. Okay. Create the ice cream survey table. We're gonna create it and put in the values inside it. So let me put it here. Create table. Sharp. And then we need to insert our values inside it. Yeah, now let's run the select statement and see what we get. Let me just explain what is happening here. So we are selecting from a table called cross tab and we're selecting the flavor office count multiply from the table ice underscore cream survey from the group. We are setting the group by in order. We grouping the flavor and the office in order, and we selecting the office from ice cream underscore, let's see, underscore cream survey group by office. We put them in order as the flavor voucher is 20, downtown big in it, midtown big in it, uptown and all of that. So the towns will be from down, medium and up. So let's see what we get. As you can see, we have the columns downtown, midtown and uptown. So we have the flavor, it's put in order. We have flavor, downtown and midtown and uptown. So why did our strawberry have a null? Why does it have a null? We probably, I don't know, or we didn't enter a certain value inside it. Yeah, maybe because of that. Maybe because of that. But yeah, guys, I hope you learned something from this chapter. This chapter is just talking about advanced SQL features beyond basic select, join, and web queries. So it focuses on how to structure queries using subqueries. So as you can see, guys, I use subqueries here and derive tables, STs to write more powerful tables and all that. So these were my values for my temperature readings table and all of that. I had to create tables. One thing I realized that you can't run a statement if you haven't ran a table, created a table yet, because the table is the one that cooperates with other values so that you can get a successful query. Thank you, guys.